We'll wait just a couple of minutes for folks to join us, and I will disable my playback streams. Let me know how it's going on your end. I'm so over makefiles. So over makefiles. We'll get into that. Just like, yeah. I think part of the problem is I know what I want to do. Beata says, light rain and not so light head allergies. Oh, sorry about the allergies. Hello, David. Hello, Sam. Hello, Deshipu. Thanks for joining. Welcome, welcome, welcome. I hope you had a good time with Foamy Guy last week. I was on a train. I guess I had gotten off the train by that point. We did a family weekend in Portland last week. Hi, QuinMan16. Hi, HamsLab. Preview. HamsLab says, hi, Scott. I'm looking forward to hearing more about the trace stuff you spoke about on Show and Tell a couple days ago. Yeah, we'll talk about that today. That's on my list. Hey, Timon. Any other hellos? How was EOS Zephr Summit? It was good. I'm glad I went. It was nice that it was during the week. Yeah, so I was there most of last week. It was just downtown. It's a mix of Embedded Open Source Software Summit and Zephr Development Summit. And there's also Linux Embedded as well. It's kind of like a Linux Foundation conference and kind of their like sub-projects. That was downtown Seattle, beautiful new convention center building. It was really interesting to talk with a lot of the vendor SDK folks. And Renode, which we'll talk about today, which is an emulator. I finally like got over the hump and getting that set up. So we'll talk about that. There was a free dev kit I ordered that it hasn't come yet, but it's on its way from NXP, one of their newer chips. But yeah, it was good. There was an interesting talk about Micropython and Zephr there. Some folks at, I forget, they just renamed. Yeah, interesting talk. How they're doing, they do kind of like, yep, exactly. I didn't catch the talk in real time. I chatted with the guy who did it, and I actually watched it overnight. So yeah, it is interesting in their approach, and it was interesting that they have their own BLE API, and it's like super event driven the way that they implemented it, which is kind of interesting. All of the information on OTA updates and stuff is super helpful. Hi, Kevin32. So yeah, that's a good talk. It's kind of like when I want to do OTA, I'm going to reference that talk for best practices for sure. QuinMan16 says, are you working on USB host for the Feather RP2040 with USB host today? No, I am not. It should work just fine. The USB host I'm working on is related to the USB host featherwing. And the only RP2040 that's enabled for is the Feather RP2040 with DVI output. I enable it there, but it's disabled on everything else because everything else has the onboard USB host via the CPU and PIO. Okay, so we're well over our 2 minutes, but hello everyone, my name is Scott. I work on CircuitPython for Adafruit. CircuitPython is a version of Python designed for microcontrollers, and it's meant to be super easy to pick up and use. It's based on Microptyon, which did the kind of like Python on microcontrollers bit, and then we've built it out as a platform for drivers and workflows and stuff for Adafruit World. And then, so that's CircuitPython. Adafruit pays me to work on CircuitPython all the time. They have for 7.5 years or something. So if you want to support me and everything that Adafruit does, I encourage you to go to adafruit.com and purchase stuff there. For example, here is an ESP. I just see what I have on my very messy desk. This is a feather, and it's got, under here is a little chip that has a CPU in it, and this is an ESP32S3. So other people make the microcontrollers, the little tiny computers in here, and then what Adafruit does is puts them on printed circuit boards, like this one. The circuit board is actually this bit here, and it's a way to wire a bunch of components kind of all fixed to the board itself. And how you break it out and form factor and stuff is really handy, and what you have built in is also really handy. So that is a brief deal with Adafruit and CircuitPython. The other thing a couple things I say at the intro, there's two chats. I always say it's the wrong way. Two chats over here. The middle one is Discord, which is a chat service that lasts kind of all week. The other one is the YouTube chat, and that goes away when the stream is done. So if you want to chat all week, I encourage you to hop from the YouTube chat to the Discord chat by going to the URL adafru.it/discord. That will get you in our Discord server, and we'd love to have you all week there. We do CircuitPython development in the open there kind of all the time. Lastly, this is a deep dive. I tend to do these every Friday, 2 p.m. Pacific, for 2 hours. If I'm busy, Foamy Guy or on paternity leave, Foamy Guy Tim has been awesome at filling the deep dive spot when I'm unable to do it. So thanks to Tim for doing it last week, and then probably not next week I'll be here, but the week after I'll be gone. And I actually have to ask Tim about that. So hopefully he'll be able to do that too. But I'm happy to take questions. So if you have questions about things, I answered a couple of them before doing this intro, but I'm happy to entertain more questions. I struggle personally documenting things really well. So by doing 2 hours of just like showing you, it's an easy way for me to get you up to speed with what I'm working on and how to do stuff. So that is that. Let's see what Kevin says. Kevin32 says, I have the Giga, but I'm confused of the SPI header since Adafruit uses SPI1, which is the 2x3 pins on the Arduino Giga board. I'm confused of the SPI layout since I'm trying to connect the MP3 shield I just bought. So SPI on Arduino usually does go on those 2x3 pins in a standard way. That's about the extent of my knowledge, unfortunately. I don't do a lot of Arduino boards, and because they're made by Arduino, not Adafruit, and I also don't do a lot of Arduino code. Does Adafruit have a Twitch channel? Yes, we do. And it should be, so we use an intermediate service that streams to more than just YouTube, and it should be going to Twitch. Yeah, it looks like we're streaming to Twitch. I think it's just twitch.tv/Adafruit. Kevin, if you bought the MP3 shield from Adafruit, I'd encourage you going to the Adafruit technical support forums, where folks who know Arduino better will be able to answer your questions. That's forums.adafruit.com. Yeah, forums.adafruit.com is the technical support forums. All right. So I had kind of two topics in mind. I actually had a third topic, but I don't think I'm going to get to it. So, or 4 topics. Let me just tell you the things that are on my radar. The 2 things that I really want to do before the weekend is I have a PR out to add a Renode port to CircuitPython. Yuri asks how much Adafruit earns per month. I don't know that off the top of my head. The better place to ask that is through the, on Wednesday evenings, it's 5 o'clock Pacific. There's Ask an Engineer, and at the end of that show, it's an hour-long show. At the end of that, Lady Ada and PT, who run Adafruit, will answer questions like that. I would ask them there for the how much Adafruit earns. That's not really my jam. My concern is whether they keep paying me, and they keep paying me. So That's all I can tell you. Kevin32 asks, any soldering helping hands would you recommend? I have a small desk. What are you soldering? That's what I would ask, is what are you soldering? I've never had great luck with helping hands, honestly. So if you're soldering two wires together, I just saw, and maybe it was at Adafruit. Let me pull up the thing. And you can see the little top of my, ooh, fancy. This is an SVG that's doing this animation, I think. I think I might have seen it in new products. Maybe not. If you're doing wire to wire, I saw this helping hands, and I'm not sure if it was on Adafruit or somewhere else. But it was like literally just something that you slot two wires in to kind of hold them right. Yeah, this is what I'm thinking of. So this is what I was thinking of for if you're doing wire to wire. Small boards like Adafruit small boards or Arduino boards. I'll tell you what I do. I usually just use a breadboard. That's usually what I do is if you're soldering something to a board like headers, right? Like if you're doing, maybe I have it, I can even show you. I have, so if you're doing like these headers, right? So you're, switch modes. Say you're like wanting to solder, come on, the headers on something like this. So what I will do is I'll put regular headers in the breadboard for these spots, and then I'll sit it upside down on the breadboard and kind of like push down here to kind of get it all settled, and then just go down the line. If you're doing components on a board, if it's not headers, then I think the one that I like, I think it's an Adafruit one as well. I need to get this wrist strap. I think Adafruit carries it. Work holders. I've never had good luck with these. But if you have, well, I wouldn't even recommend it if you have vision problems. If you have vision issues, I would get a visor. That's what Dan does. Yeah, I haven't had good luck with these. I do not recommend these. Heavy stainless steel PCB circuit board holder. So this is something I would recommend if you're doing like Adafruit flat boards, if you're soldering more things to that. I would do this. I've had better luck with like a Panavice Junior as well. I do not like these, and they've been discontinued, so it doesn't really matter. But these things are not fun. They never worked very well for me. So that's kind of a. I have not used this one, but Timon is saying that they've used it and it works well. So hopefully that's a little overview of my experience with soldering stuff. And Ham's Lab has a print as well. Okay, so things on my radar. One, Toddbot filed an issue saying, hey, you haven't actually turned on the USB host support, the USB host featherwing support on ESP. I'd like enabled it just for one board and not done it kind of blanket. So I'm working on enabling it for pretty much everything. Yeah, the stick vise, yeah, I like that too. So that's kind of what I'm doing right now, is trying to get that building and ready to go. And then I also have a port for Renode. So Renode is an emulator that is geared towards microcontrollers. So in theory, they want you to be able to take stock firmware for some particular micro and then just load your ELF on it and run it in the emulator. I did try that in CircuitPython, and I could actually show that as well. But the issue is that they don't necessarily actually emulate all of the peripherals and all the registers of those peripherals to the point where like CircuitPython didn't run. So what I wanted to do instead is I'm not actually interested in peripheral testing with Renode. What I'm more interested in is having better insight into the execution of like the Micropython VM generally. And so my approach was to do a new port of CircuitPython for Renode. It's meant to be super minimal. It's just UART in and out, and it loads the fat file system image into the emulator kind of stock. So you can just say like, here's my code.py and run the emulator. I'm happy to show this. I think I want to finish the ESP stuff first. And then, yeah, so because it's an emulator, it has a lot more insight into like all the memory accesses you do, how many instructions you're running. You can do really cool things with that information, and it's just way easier to get out of an emulator than it is necessarily like an actual device. So, and then that emulator can run in like GitHub Actions as well. So one thing that's really been interesting for a long time is being able to, whenever you update a library, being able to actually import it into the VM and just measure how much memory it uses to figure out like how memory use is changing with libraries over time. And potentially we could even do it for like Learn guides. So in Learn, we now have project bundles, which will basically give you like a code.py and all of the libraries that it uses. In theory, we could run those in an emulator as well to give us to be able to measure memory use largely. But in theory, we could actually run the whole, well, depending on how complex, we could actually start to add like I2C support to mimic things like that too. So my approach has been to have a new port of CircuitPython so that I'm more interested in seeing how CircuitPython execution changes across CPU cores and also across like memory layouts. Like Renode doesn't do like how many cycles does a certain instruction take. It's not to that level. But there are cases where like being able to test whether if you run something from this memory space, it ever jumps back, that sort of stuff could be really interesting too. So yeah, generally it's pretty cool to just get that insight. And I'd like to get, I showed a trace on show and tell. I don't have that open again, but I could open that and work on that too. So that's the second thing. 2 weeks ago on Deep Dive, we ended up with getting a Clang build of the Feather RP2040 or the Pico RP2040 built with Clang, but we didn't test it. So if we want to revisit that, I do have a Pico with headers right here that we could test the Clang build stuff. And the last piece of that puzzle, I think is the last thing I was thinking about, is I really want I want a better build system. And today I've been digging in the make files today, and it's just kind of outrageous. Like you're doing logic like if this or that, but the idea that you don't have like an actual language to do it is just kind of absurd to me. So I've really been thinking about what my ideal build system is, and kind of have landed on this like, I just want CircuitPython to do or I want Python to do everything, and I can use async IO to manage all of that and manage concurrency. So you'd have one Python process then calling out a number of other like compilation stages at the same time. And this is not my idea. This is what Honcho does. But I think I was thinking with the pickel for Clang 18, for the Clang build, I was really thinking about like what my ideal like user interface to building stuff is. And I just want to be able to say, hey, build pickel for this microcontroller or this CPU, and it just does it. And so I want the build system to have a bit more smarts around around all that. So around knowing like CPUs and CPU flags and things like that. So I'm working on that. I started a new repo. And every time I dig into CircuitPython's make files, I wish it was just all Python. So yeah. And then this VisTrace thing looks really cool. I was thinking like, oh, wouldn't it be like, I've been doing tracing for the Renode stuff, but then I was like, well, for a build system, I'd love to be able to trace the execution of a build system too, and that's another benefit of using Python, is that there's already existing tools like this, like VisTracer, that will do trace captures for you. And it also does async. Like it can work multi-threaded, multi-process, and also async. So how cool would it be that you could actually see different, to trace your build using these tools that trace code execution. So yeah, I'm getting there. My brain is like wanting to work on it, but I know it's not like top priority. I guess that's 4. And I don't know if I talked about, I actually spent some time this week starting the ESP32 BLE work, specifically getting GAT servers running. This is a long-standing feature that allows you to do a whole lot more with BLE. And my goal is to get it done by the end of next week, but these PRs have been taking a little bit more work than I thought. So we'll see if I can actually get it out by next week. So that's on my radar. I got it compiling, but I haven't run it yet. And I don't really want to like open that can of worms until next week. So that's my brain dump in terms of all the things I've got going on. And now I'm looking at my desk, and I also did get a Digikey. Once or twice I've done Digikey unboxings, so I did get a Digikey order. So first I got, this is the Digikey label. These are, I'll just open these. So I did a Digikey order. So this is the ESP8684, also known as the ESP32C2. It's weird that they're like named differently, but I think this is the C2. So we're doing more and more work on the ESP32C series, so having C2 dev kits would be nice, and they're cheap. The next thing I got is ESP32C6 dev kits, because the ones that I have from Espressif are actual like pre-production ones. Like at some point they went on Twitter and says like, who wants one? So I got something pre-production. I actually wanted to get kind of like later silicon in case things changed. And this also, like these have BLE as well. So the BLE work should work on the C6. We have a new ESP32C6 feather from Adafruit as well. So there's more ESP work in my future. Lastly, I got one more board. And this is a S3 feather, or not feather, S3 dev kit, but it was in a different flash configuration. It's an N16, so 16 megabytes of flash and no RAM. Generally, I just like to support all of the different ESP dev kits, and that was a new one that popped up on Digikey, so I picked that one up as well. Just an S3 with 16 meg flash. So that's what I got. And then the reason I did the order actually is, let me show you my not bench cam. So I got, if you do anti-static stuff, I need your help. So I got this anti-static mat that my chair is now sitting on. See, this is the chair I'm sitting in. And I have a drag chain on it, so the metal part of my chair is hopefully grounded to the mat. And the mat is connected to a screw on my outlet. But I'm still having I'm like still shocking things, especially when I like scooch off my chair. I can actually zap like the bottom of the chair. So I think I might need to go to like a wrist strap or a heel strap in order to like, yeah, floor cam. Not super exciting, but you can see my anti-static mat. And I'm still zapping things, so hopefully it'll be better still, but yeah, I really do zap things a lot. Yeah, I like this chair too. It's okay. It's not magical, but. So that's my Digikey overview. And I should say Digikey does support Adafruit from time to time. By working with them, so like to give them shout outs too. Okay, so let's go to this build. I've been fighting it. Oh, and it looks like it, oh, it didn't work. Oh no. 47 successful and 461 failing checks. Great. That's what I want. So let's see. I broke. No rule to make target. I wonder if I didn't include that file. So this is my desktop view. Thank you. I swear DCD pays more attention to the stream than I do. You have any non-synthetic fabric you could try for an imprecise slip cover on the seat? I haven't thought about that. Okay, so this is me debugging my crashing USB. Seems to be okay. My guess is that I need to git add supervisor shared USB device. I split things out. This might be it. So one of the challenges, so this is in theory squeezing the max support into the ESP32 S2 and S3. But then I was like, oh, but wouldn't it be cool if we actually had it on the C6 feather, which is not native USB, but we don't need native USB host to do this. You just need, you do a SPI to the featherwing. And it turns out like literally like last night, TAC was working on the same thing for Arduino. And so this now updates us to the absolute newest version of tinyusb as well, because he fixed it. So, and then I did some work in CircuitPython to make it clearer when we're doing USB device and USB host, and when, and if we need tinyusb for one or the other. C6 superpowers. Yeah, C3 will be, well, assuming it fits, C3 should work as well. I did, it does also blanket set for boards with 4 megabytes of flash on ESP, they'll auto default to optimize for size instead of optimize for speed, O2 versus OS. So I pushed that, and I think I actually just kind of want to wait. Thin Man says, GitHub is so vast, where would I find modules in CircuitPython 9.4? Would like to see how audio MP3 works. Yeah, I can show you that. So the structure of Adafruit CircuitPython is that shared bindings directory here is the layer between Python and C. And then, so this is where you define like the API of audio MP3. And then because it's not port specific, shared module is where shared implementations, aka non-port specific implementations live, which I think is where audio MP3 lives. So there's here's MP3 decoder, and here's the source for it. So I'll even just drop you a link too. If it is port specific, the place to look is like CircuitPython ports, the port you want, and then in Common HAL, you'll see all of the different module names here too. So that's where, when it has a port specific implementation, it lives. Dexter says, question about NVM, can I pickle a dict and reload it later? I think somebody wrote a helper method to do that. So probably, but I should caution, like, don't plan on, like, NVM is really writing blocks in NVM. It doesn't do any sort of balancing, usually. I think ESP does actually have something else under it, but I think there is a library to do it. I don't remember off the top of my head what it is. Mike Jones says, for going back to helping hand stuff, get a big wad of Play-Doh and stick a PCB in it. It won't move, works in a pinch, and if you don't have helping hands. The Play-Doh melts and gets messy though. Mm. Yeah, and Dishipu points out that like it depends on what's in your dictionary, whether you can serialize it as well. Okay, so that's a quick where do I look for things, and that's a perfect question for deep dive. So we're gonna let the CI churn. Oh, talking about the Zephr Dev Summit thing and embedded Linux and embedded open stuff last week at the conference I went to. One person who works on GitHub Actions was there. And I was like, I just happened to chat with them during lunch. I sat down and had lunch with, like, turned out that's what they did. But I was like, oh, thanks for all the free CPU cycles. And he was like, what project are you? And I was like, oh, Adafruit CircuitPython. He's like, oh yeah, like that does ring a little bit of a bell. I did work in abuse for a little while, trying to find projects that were kind of abusing it. So we're up there. They did tell me that it was like the Apache software, like open source software, like the web server that is the most the biggest user of GitHub Actions for open source projects. Beata says the blue-gray tack stuff is a little easier to work with and so far hasn't left any residue. I've had problems with blue tack on walls leaving stuff. Oh, and Sam says ESD chair covers are apparently a thing. So Desco is the people that I ordered that from, so the problem is my chair is not that shape. I'll have to come up with something. The other problem is like, if I slide off my chair, then I may not be touching my chair anymore. Beata says they're using some of the blue tack to cover up all the battery charge LEDs. See, that's the drag chain like I have. ESD pants. Well, see, I know that they have like heel straps, right? Like where it goes around your ankle and then down to the floor. Like maybe that's what I need. I don't know. We'll see. I've gotten the habit of just touching this metal part here, and at least I put a drag chain on that too, so I'm hoping at least that means that I'm not going through any like USB bus, because I've like reset USB devices when I zap things. Okay, so let's talk Renode. Is that fine with folks? While this runs, we're gonna the large metal ball in the set. Golden chainmail suit. You also get ESD shoes. I don't really want ESD shoes. I don't want different shoes. But yeah, definitely humidity is a problem, and that was my first thing is I got a humidifier, but it's actually, I think it's kind of a pain. It's kind of a pain to keep filled with water. So yeah, that is part of the problem. I mean, I have like this thing that you can get from the shop, and it says it's 41%, which is a little low, but not as bad. ESD Crocs. I'll probably end up just getting a wrist strap. As long as I get off the chair with the wrist strap on, I'm probably okay. Your wrist strap wouldn't be too bad. Pirate style. Yeah. Okay, so Renode is cool. Let's talk Renode. So the other thing I have is, actually I need to pick up where I left off. So let's do this. And get pull. So I accepted some suggestions on, or did I? Oh, you know what? I haven't done it yet. So GitHub has this cool feature where you can So it has this cool feature where somebody else can suggest changes, and I was doing add suggestion to batch and then marking it resolved, but I think that actually, like, if I hit resolve, this number goes to 1, and then if I hit resolve, it still stays at 1, but it doesn't, it like undoes the suggestion. So I just have to say add suggestion, and okay, so now it's 2. I was trying to, like, Dan did a bunch of these suggestions, and I looked up how to do them all. At once. He was nitpicking me, so I think he felt like he had to do it. Mark says, I know the pain of refilling humidifiers all too well. 41 should be enough. I normally see it sub 20. Wow, I have not seen sub 20. Sometimes in the 30s. Zapping my feather too much, so I use knock detection instead of a button. Really static inducing fluffy jumper. I mean, that's kind of between my butt and the seat. Like, I could slide off, and, like, if I put my hair, like, my arm close to the chair, like, my hair will stand up. Because, like, it's very clearly, like, not grounding down or something. Yeah, so this is kind of annoying. But do I have any others? I'd like to do them all in one batch. How many are there? 9 conversations, one of which doesn't have a suggestion. So I have all of them. So I'm going to commit changes. And now I'm going to do the pull again. So this is the tricky thing with doing accepting changes. Right, so now I pulled them down, but Dan also asked me to rename a file. So I'm going to git move. So this is cool. This is actually like you can dynamically load stuff. So let me show this. So this is the same window from show and tell. And I'm actually using a custom version of Renode because the profiling wasn't working quite well enough. So I worked on it, fixed it. So I have, okay, so that needs to be updated too. Renode. And okay, so include basically runs all this stuff. And you can say I, but I should write it out because it's easier to read. Okay, so I don't know what using sysbus says, but we include this. I created this fake peripheral that keeps track of time, like in units of like 32 kilohertz. Like you typically get with an RTC clock. So I use that for timing in this kind of fake port. So the idea is that all the peripherals are the same, but the CPU could be different. Right now it's just an M0 plus, but in theory we could add more CPU, different CPUs to emulate. So custom peripheral, and then this hooks up the UART to a PTY, so you can actually TO to it. We pick the board, we create the board, just giving it a name. I tried to put $board here, it doesn't work. This is some weird like monitor sort of thing. It's very weird. Somewhat north of Vancouver, it's always around 40, even when it's been raining for 4 days. Yeah, it's been raining here, and the window's open, and I'm at 41. So yeah, for sure, I'm right there with you. So you can record the serial output, but I'm not doing. This connects this to the PTY. So this loads our firmware image. It tells the CPU to start where our interrupts table is, which I put at 0. It also loads CircuitPy.image, which is like a FATFS image of, there's a CircuitPy folder that has a code.py in it, but in theory you could put libraries and stuff there and different code.pys to run it. You can set log level, you can do profiling, you can do execution tracing, which is slightly different, where you actually get every instruction that gets run, along with it, you can get it with a disassembly. And then you can also have it do GDB, so you can connect to it to a debugger, which is really cool too. So that's that file. I fixed the name. So let's go back here and try it again. And it failed because if you crash, your temp URL doesn't go away. So we're gonna just remove that and rerun. One thing I haven't figured out is how to reset the machine without like turning Renode off and back on again. No such command or device. Oh, so it is actually, I assumed MACH was short for machine. And you can see here actually that TO is connecting and disconnecting as the emulator sets it up. So now if we do that, we can hit start. And depending on the settings, so if you're like profiling it, it will take it'll take longer than if you weren't. It's also not super, super quick. Time between seeing a message here and when it shows up on YouTube, Twitch is 4 seconds. YouTube's 22 seconds. That's pretty wild. I have it on normal latency though, because I like to have captions on. So you can also do pause, because it's going so slow that when I did my demo for, I'm going to comment out enabling the profiler. And this is like debugging messages for there, see, so it comes up a lot quicker. It ran quite fast actually. So now we're basically done. But we didn't do any sort of profiling when we did that, but it just emulated. Sorry. So it emulated CircuitPython coming up on this fake or emulated Cortex M0 Plus. And then if we want to quit, and then in CircuitPy we could say like, oh, hello Nate from Renode during deep dive. If we hit save, now we have to run make again, because it will regenerate. And it turns out we have some compiler errors. Good, we're testing it. So let's fix that too. So you can see we only implement 4 modules, and I2C and Spy are actually not implemented, although there is some support for like emulation. And then I think we need, oh look, clangd is saying, hey, you should include this. So I'll hit that and it adds it. I'm like liking my, I think I talked about it 2 weeks ago, but getting like clangd, the language server set up, and copilot, like copilot is right, like for little snippets of code, it's like quite nice, especially if you're doing the same thing over and over, like it can make a better guess. Okay, so now we're in microcontroller processor, and it's the same problem. And it's going to tell us the same thing. So this is actually why I wanted to do this too. So I took Dan's suggested changes, but I wanted to retest them. Although these are compiler errors, so they would have happened as well. So now we're going to rerun Renode. And hit start. And we should see our new code.py. Any questions about Renode? I feel like what I want to show is, let's quit this. And let's actually make a, you know what? I think I could just do Renode-run. Oh, I don't have Renode-run. I did it on my laptop, I guess. So Renode-run is really cool. I wonder if Arch, you are Renode. No. See, but they have like this GitHub Actions integration, which is cool. Okay, so I'm gonna install Renode-run because I think it's cool. And I'm probably in my virtual environment already. So I'm just going to do it to my virtual environment. How do you like it so far? I've never quite gotten a chance to integrate it into any workflow. Me neither. Although when I'm like, my brain is so frustrated with makefiles that I'm already thinking about how I can move the Renode port to a new Python only build system first, because it's so minimal that like it'll allow me to focus on the core of like it has no SDK, right? Like it's just like UART is literally writing to like one register and reading from one register. So like here's the address of the RX and TX, and it's actually like a picosoc UART register. It's like super basic. And all you do is like you read it and write it, and then the emulator is just like, hey, I detected a read and write. That's it. And in fact, you know what we could do? Well, what I was going to do first is Renode-run -b. So there's this Renodepedia. So just like CircuitPython has board defs, Renode does too, and it inherits pretty much all of them from Zephr. So, because there's automated testing that Zephr does with Renode, and you can see they actually have like the Micropython Zephr port demonstrated as well. They have traces that they show. Turns out, my hate for CMake runs deep. Yes, it does. Every time I look at CMake, I'm like, why isn't this Python? And people are like, oh, but like build systems shouldn't be Turing complete. Well, programmers write programs. I'm sorry. Like, I'm so sick of it. I'm so sick of it. I'm so sick of it all. Like Python has like great tooling for understanding how something runs. It has great tooling for like abstracting pieces away. Like, and everybody wraps all their build systems in Python. I was there today because like the USB host stuff, I was like trying to change CircuitPy USB to CircuitPy USB device or something. I'm just like, I'm so sick of like, I wanted to say like, if this or that, then add these source files. I'm just like, it's not trivial like it should be. I'm so sick of it. I'm kind of thinking I'm going on this road trip with my dad in a couple weeks, and I think I'm gonna bring my laptop and just like hammer on it. Conclusion: programmers should not be writing build systems. Okay, fair. We're pretty unique in that we're building a lot of stuff. I don't know. We'll see. We'll see how we like it. You know. I can think it's going to be great now and then see later. Okay, so here's Adafruit Feather M0 Basic Proto. I can do Renode-run and then use that ID. And then let's do atmel samd build. Do I not have it? Feather M0. Do I have a build? No. Okay, I'll make a build. So this is what Renode looks like if I try to run it. That's what it's called. On a stock CircuitPython elf file, which is like what their goal is. Their goal is that you can just take stock firmware that runs on device and run it on the emulator. I thought it was -B. Oh, demo. I think I have to do demo. There we go. Okay. Interesting. So it made a temporary script file. And now I'm going to hit start. And it's going to try to run CircuitPython. But see, what's happening is that it's logging like, hey, you're trying to read 32 bits from this address, and you did a lot. And I think I looked it up, and we could look it up again. I think it's an RTC address. So like, the other way we could go, Spite is a good driver for change. I'm just sick of it. I'm just sick of it. Yeah, the poor Microptyon devs, they maintain both makefiles and CMake files. Like, they're not in any better world. They're just doing both. Like, I mean, it's interesting, right? Because, you know, we use makefiles for both building and configuring, right? And I think in like Zephyrland, which is where my like kind of our brain has been, is like they use kconfig for all of their configuration, and then that pipes into their build system, but they still have build steps that are Python. And they use CMake, which generates Ninja, and like, I don't know. I think, and I'm like, I'm not trying to do a general build system. I'm trying to do one that's for embedded devices. In fact, I pushed it to PyPI. It's called Embedded.build. And I actually bought the domain Embedded.build. So I was reorganizing it last night. I'm quite happy with it. CMake is not something I love, but it's bearable. I always see CMake files that look like they should just be Python, like if statements and for loops and stuff like that. And I'm just like, what's the point? What's the point? And then like if it's all async IO, you get like VisTrace for free, in theory, right? Like, Tishipu says, Jinja 2 templates of YAML files that get fed into Ansible that calls Puppet and then packages that as RPM and puts it in a Docker container. Yeah, like, yeah. I like had a discussion about this with Dan not that long ago where it was like, I was going to do Python that like read TOML files. Oh, that's what you do at your J job. I'm sorry. Like, and Dan's point was kind of like, why do TOML? Why not just do Python all the way? And then with the honcho stuff, I came up with this kind of like, there's a function in the board folder that calls, like kind of customizes the port level build, and the port level build calls a top-level CircuitPython build sort of thing. And if you do it with async IO, then you kind of like, you can still be concurrent or at least asynchronous between those two things. So yeah, so getting back to Renode, this is kind of like the really cool, well, this is because it's not implemented, but you know, you can get much more insight into like your code and logging all of its memory accesses, for example. I've spent a lot of time trying to get like the ARM trace output working from a trace core, but like this emulator is going to do a better job at that. If you want to analyze how your code's running, like it's not going to really be able to confirm that your peripherals are right or that your code works with the peripherals in the correct way. But yeah. I mean, the risk with doing it all in Python is that it's slower, right? Like, potentially it's going to be slower. That's fine. It'll be a lot more maintainable. And, like, you can still do the, like... you can still do the, like, tricks of, like, I don't need to rebuild this sort of stuff. Except you can do it in a way that's, like, actually accessible, and you're not kind of, like, at the mercy of some system you don't have insight into. Okay, so this Renode stuff works. Let's, and we did the changes that Dan asked for, so let's finish that thought. Maybe I should show, I wonder if I can do run macro. Reset. Oh, I can. So I think this is like a standard. Yeah, see, so it's just doing that. I actually tried 3 different ones, but they all had missing stuff. I tried NRF and STM as well. I got to figure out the reset stuff. So it looks like it just reloaded like the state of everything. And you can automate some performance regression testing down the line. To some degree you can, but it's not like cycle accurate. It's not cycle accurate, it's instruction accurate. So you don't actually know like what you're using instructions that are fast or slow, but you can get a general feel for like how many instructions you need. Actually, let me just show the trace. So the problem that I was running into, I have this ideal of what I like. So this is speedscope, and this is just a generic trace of something. But let's see if I can't find the file that sorry, I just gonna look through my drive. Let me see if I can open the trace. So I was having problems that CircuitPython calls a lot of stuff. And it's kind of hard to see in a trace the things that are interesting. And one thing I'd really like is I'd like to track memory use. So what I'd really like to be able to say that, as far as I know, Renode can't do is like, hey, like in my profile where I'm doing the, let me get this loading. Because if this works, it's going to take a little while. Ports, Renode, code.py, open. I mean, TOML's fine, but like, why use TOML when Python's fine? And then the nice thing, so one of my beasts with honcho, and generally folks that use Python because Python's easy, but they're not actually like users of Python, is that they ignore all of the API documentation and tooling stuff. So like honcho, it's just like, oh yeah, like you have a config and it's just key value pairs and like never talking about like how you document what the keys mean. And so moving to a system where you're like calling a build function and the build function has keyword args and the keyword args are documented. It's like kind of nice. like having things documented is the way to do it, in my opinion. And so like being able to put up those API boundaries is cool. And then I showed this 2 weeks ago, I think with the I was starting to sketch it out in the one file to build pickel.libc, and now I've split it out. But having like core types for embedded specific things. So like configuration management is a whole separate domain. But I think I'm trying to do that too, because I'm just using code to set settings. Prefer Node for scripting like that. See, I've not gotten over the Node hump. I've been a Python user for too long. Yeah, there's speedups you could do with, like, Google does things like cache build output across people. Like, we're definitely not going to do that. And Ccache could do some stuff, but I don't know how much time we spend just doing all the C preprocessor. Everything touches everything else. Okay, so this is speedscope, which is one way to view files. One gripe I have of mine is that they use the scroll wheel on the mouse to go up and down, which is not what I want. I want it to zoom. But what you can do, I thought, is that you could, oh. What the heck? That's not what I expect. So this is a trace. This is a section of a trace that I've done before. It's not anything I did today. This is the same one I showed on show and tell. And you can see that, okay, so when code starts up, you go into reset handler and then you call main. So these kind of, is it control scroll wheel? No, it's not. I think that's still control. So this is still here, but I was trying to capture just when we are in run.code.py. And like, this is like, so these numbers are in terms of cycles. So there's a serial write that delays for, I guess this is 5 seconds. So that's not quite right. But asynchronous node is a whole lot more readable and expressive. Oh, interesting. See, I've not done a ton of async IO either. So that might be my downfall. So usually I expect to be able to, oh, here we go. Yeah, so what I can do is I can select just a tiny sliver, and you'll see that like most of my trace is actually in this delay milliseconds thing. And like at the bottom, these are like little tiny like checks for running background tasks. And then I'm zoomed in and it's still like, okay, so that 12 is like the number of instructions that it was in that function. So this whole thing is really not the part that I care about. Alternatives like trio. So what's more interesting to me is it turns out it's like this chunk. And then towards the end here, all these background calls, this is just idling after things finish. So like this, well, one thing I'd like is like when I do like this serial write compressed, I'd love it if I had like a bar here that told me like the characters that were being out on the UART, so I could like see. And maybe that's what I should do is I can trigger on UART stuff. So what I'm trying to figure out is how I can get like enable tracing just for this like chunk that's actually running, actually doing the execution of the Python file. So what we can see here is, So we're done with the serial write. And this is, so I think the first time he writes a serial, we do a delay, and that's what all that left-hand side is, which is kind of silly. And I commented it out, and it makes it a lot quicker to run everything too. But it shouldn't be running for that long. I feel like I think it's a 50 millisecond wait, and yet it looks like it's going for 5 million instructions, which would be 5 seconds. No, that's right. Because there's no concept of CPU speed necessarily, but by default, it's 100 million instructions per second, I think. Why was the serial delay added? I think it's for, I don't know, we'd have to look. The very first time you transmit, it's just trying to like let things get set up before you do your first transmit. It might be a USB thing. I don't know. But it's not port specific code, that's the problem. Anyway, so here we can see start Micropython, and it's doing some like allocations for starting Micropython, including the heap. And it would be cool. I would love to have 2 counters here. So speedscope can't do a whole lot, but there's this there's this thing called Perfetto, which is a Google thing, and they have a lot more different kind of types of tracks, which are really cool. And I did this a little bit, I think, when I was trying to do the actual tracing stuff. Ooh, I'll have to look at that. I wish Thea wasn't on Twitter anymore. I will look at that later though, because I'm trying to be family friendly. I guess me scrolling around doesn't make it go away. So this is open the UI. This also doesn't just do zooming, which drives me kind of nuts. But this is kind of yeah, so it has a similar view, but they also have this view for like, can I make it a little bigger? Yeah, so this looks really neat. So you can actually track like what different CPUs are doing. And you can track, this is actual CPU frequency and if it's in idle mode or not, which I think is really neat. So in theory, like Renode knows whether it's, Renode also knows whether it's a like idle or not. So in theory, we could annotate this too. And then they also have these tracks, so you can we could actually graph over execution time the memory use of both Micropython and the outer heap now, which would be super cool. So I'd love to be able to do that with Renode, but the problem is that right now the profiling is done from the CPU's perspective. It doesn't it's not hooked up into the UART system. And it's not really the memory system either. I want to be able to say it uses debug symbols to find symbols. And so I want to be able to say oh, when you're profiling, also just track writes to this one value and chart them. So I could add to GC just I already did this in my other branch, say have a global that's just how many blocks am I using in my VM heap? And just as I allocate and deallocate stuff, I'll just write to that variable. And then what I can do in the emulator is say hey, watch for writes to this variable and then chart them along with my profile, which would be really neat. So yeah, I think this stuff's really cool. But there's more work to do to make it really helpful. Largely because of this idling problem. And you'd actually the trace would go way faster if you just enabled it for a particular slice. And then yeah, there's a lot of noise at the bottom too. To avoid handshake timeout. No, I think, where is it? mp hal delay ms. That's the function call. And it's in serial. This is the one I think we're hitting. If CircuitPy console UART, if not first write, done, delay 50 milliseconds, and then write things out. And we can look and see when it was added. And it was added by Dan. Oh, I clicked the wrong thing. Fixes 6892 in other cases in which serial output, usually USB output, is fed back into the REPL input as noted on Linux. They open the serial channel in echo mode first, in which serial output is echoed back to the serial input. Then they immediately turn it echo off with ioctl. But there's a race condition. Yeah. I think you probably had a hash in front of it, and it's doing markdown. That's why it's giant. Yeah. It even crossed my mind to have trace I don't know, trace control from within CircuitPython in the code itself. But I don't know. So this is what happens when you execute. So you write here's the code output. I think that's what it is. You call start mp, which does sets up the heap, and then change directory, import stat. So this is, I don't know what that is. 2 imports. And then you write something else. You update the status bar to say you're running, and then you execute the file. You construct the lexer, which is VFS open. It's interesting to see flash read blocks because it's 1-to-1. It's just a mem copy. This is a mem copy at the bottom here. Because we're not actually doing SPI flash. So this chunk right here would actually be longer if we're not in SPI flash. We're doing QString stuff, lexer new, mem set, dictionary store, and then now we're doing a parse. So that's how, so kind of starting the file for lexer, creating the lexer, and then parsing is 50,000 instructions. Compile is another 10,000 instructions. GC collect, I think this is, this would be interesting too. Is 6,900 instructions. So that's after you do an import. And then you call function, and this is in your main. And I was thinking, oh, also how cool would it be if you had once you do this, you actually get a second trace here that's actually the Python call stack. Would be super neat too. So call function entry is 2,300 instructions, and then we're done. We update the status bar to say we're done. we write out that we're done, we clean up after the VM, and we write something else out. And then we're just idling. So like, it's amazing. I mean, this is just for the print hello world, but like the execution part of this is teeny tiny, like 2,300 instructions. Speedscope showing different threads. It's not. This is a call stack. But I think it can do different threads. But Perfetto has a lot more stuff that you can show, not just this. Yeah. So that's... So we're still failing some stuff for ESP work. And let's see how our Renode build is doing. It also failed. It failed to build. But did I push it? Oh no, I didn't push it. Okay. So... Is there anything else I should show for Renode? There's a lot of cool like logging stuff. Like you can have it log function names. You can have it log memory addresses. Emulation, run for... I don't know what nearest sync point is. And Renode can actually do multi-device stuff, which is pretty wild. USB connector. Like there is a way to do USB into your device too. There's a whole lot of stuff that I just don't know yet. That mock I2C host. Yeah. David says that it appears that the visualization of the call stack over time, like you've shown, can really enable understanding of some problems. Yeah, I think so. Especially when you're digging into the VM, I think. Yeah, especially for VM stuff and memory management stuff. Things that are... The reason I want those things in an emulator is it's like still it's still pretending to be 32-bit. Whereas, like if you run it on Linux itself, you're in 64-bit mode, and that's like a pretty big change in terms of like how CircuitPython runs. And I'd love to see just like those cycle counts, how they change between like an M0 and an M4, or even a RISC-V. And you could do analysis of like OS versus O2, like comparing how things run instruction count-wise between different compiler modes. Anyway, there's lots of cool stuff here. Getting the exact chunk of profile, because that was like, that profile I loaded in was like just under 100 megs. And I filtered it out of like 2 gigs worth of profiling data. Like there's a lot of noise in there. Because when we idle, we're idling like in loops that are calling functions. So when we idle, we generate a lot of profiling for not a great reason. Yeah, so that's kind of neat. Let's see where I want to push it. And I do actually, you can see that I have this like profile folded, and then I was starting to work on a script that like splits them out into like boot.py, code.py, and supervisor. But it's not good enough to really give me the chunk I want. Okay, let's go to merge and do discard, stage, stage, stage. Okay. The hump that I had to get over with Renode was like defining a machine from scratch. So the Renode-run was really the thing of like got me to the point where I can like, take a look at it. Does speedscope allow you to mute the profiling when doing useless logging? So speedscope is just viewing a log, but that's kind of what I want. Is I want to make it easier to log just when I care. Like I could do it as post-processing, which I've explored a little bit, but then the emulation runs real slow. So ideally, and I think it might be that I have to actually use GDB, because GDB I can say set a breakpoint at this point and that point and kind of run it until it hits the first one, and then run some commands from GDB that turn on the profiling, and then let it run again until it hits the next breakpoint, and then turn it all off. Like I think that might be the best way to do it. Like there's ways of scripting GDB to do something like that. Like you can actually call GDB with like a script, and it would do it all automatically. So that's probably the way that I would do that. And I could actually, we have like 30 minutes. I should get this other building, but that is something we could do if we have a little time. The problem is that it still doesn't answer the question of like how do I get variable monitoring in there, and how do I get UART monitoring in there as well, like so that I have like all of the same time scope. And that also reminds me that the GDB scripting is the trick that I used when I was doing the memory analysis years ago now, where I was actually like setting a breakpoint on something I inserted into the GC, and then I was like literally dumping all of RAM and like just storing every copy of RAM and then doing post analysis on that, which is something I could do with Renode as well, but without needing a device. It doesn't. The Renode profiling doesn't allow you to mute stuff. It only allows you to like limit it to certain prefixes. So yeah, I don't know. I haven't figured out exactly how I want to achieve what I want with that. Okay, so let's see what's not building here. Like Dan already said like, oh, this is great, but then realized that nothing built, or a lot of things failed. So let's see what is failing here. And 46 could actually be, oh no, it's expressive. I was gonna say it could be like the ST port, but it looks like it's ESP32's one Nordic board, a couple RP2040s. I am totally here for the world where Python tools get rewritten in Rust to be faster. Like, yeah, I'm here for that world if need be. Okay, let's figure out why. Let's fix some builds. Config TED enable is not defined. Okay. I can define it. So let's go. We're switching contexts now that our CI run has gone. So we're going to switch back to squeeze. And let's do make board expressive ESP32i. I think another gripe I have about build systems is I really would like it to be easier to refactor. So one thing that I've kind of had in the back of my brain to make our builds faster is being able to do, like, and SAMD21 builds are really slow because we do LTO to make them small, but we have to do that for every translation. Whereas if we got a little smarter, we could do the LTO once and then do a link after that to link in the translations. And that would just like speed it up a lot because traditional links are a lot faster than LTO links. But like manipulating the make files to do that is kind of a huge pain. Okay, so we're not in Renode land anymore. Where we are actually is, I think I want to go into supervisor, tinyusb config, and instead of doing it there, I'm going to always define it, and I'm going to define it as CircuitPy device. I also want to be better about isolating command line flags, right? Like right now we have a C flags global. That means that like when you add a flag to C flags, it gets applied to everything, which is super annoying. Sam asks, related to a project they're doing, is getting visibility into VM internals related to what you've been thinking with Hazard3 plus OrangeCrab stuff? Tangentially, but because I'm curious to see what CircuitPython, what those traces look like on a RISC-V like Hazard3. But I'm actually interested in like having a custom system on chip where we could do like NeoPixel peripherals and stuff and in the OrangeCrab, which we could totally prototype with Renode, because Renode has a way to hook into Verilator or something, which is an emulator for FPGA gateware. So like Renode could be helpful for that. But no, with the OrangeCrab stuff, I'd love to actually run CircuitPython. Like I'd love to have a cool like custom CircuitPython sock on the OrangeCrab. That was like, if you made a system on chip, what would you, how would it work? Ideally for CircuitPython. So I'm, the core stuff is interesting, but it's not just that. Okay, undefined reference to keypad, but that could be because I didn't clean beforehand. So let's just try it one more time. Seems like I fixed it. You're going to talk about how you're using Renode gets me thinking of gateware that could have some kind of hardware trap and FIFO thing to siphon off UART stuff, or maybe stream the program counter out on a debug UART. There was on the Adafruit blog recently, there was talk about SUMP3, I think it was, which is like a logic analyzer, like shuffling out wire data, kind of that. Yeah, you could do introspection and things like that too. But it is kind of nice to not need a hardware device. I guess, yeah, my answer is I want the, I think the OrangeCrab stuff could be cool, so you could actually use it in projects. Like that you could actually use, like, I'm not convinced that anybody's gonna, like, I'm not convinced that most people will create a custom system on chip to go in the FPGA on the OrangeCrab. But we could, like you and I could, potentially put together, like for a given project, here's an image, right? Like here's both the system on chip and CircuitPython designed for it. Now you can have custom UART blast, like custom peripherals that blast NeoPixels in the same way. Or, you know, some other, like here's a dual core one. I've had this this vision for a while. Like I had a discussion with, what's this called? I'm blanking on his name. He goes by FPGA helper for a while. He used to work at Lattice. Greg. Yeah, where one way to get into FPGAs was instead of doing system on chip stuff like the OrangeCrab, you could do like FPGA helper boards. So like the mock X02s from Lattice are supported by Open Tools a little bit, and they can be loaded over I2C. So instead of having this model where like CircuitPython's running on something, you could actually have like a helper stemma device that you load something over I2C and then talk to it over I2C to do something special for you. And I've been thinking a lot about this actually because FPGAs are expensive, but you could have the same model for a cheap Cortex M0 Plus. So like the STM G0s and C0s are really cheap. So you could actually have this model where you have like some tiny piece of C code. I have this prototyped. Where is it? Let me find it. I think it's, sorry, I just want to find it before did I do it under Adafruit? Stemma G0, is that what I called it? Maybe it's under mine. I think that's what I called it. Huh. There's the KiCad. I don't have the project. So I made this like little stemma board that has a Cortex M0 on it. It's meant kind of as a replacement for Seesaw. What did I call it? What did I call the? Because the problem, one of the problems I ran into this was I actually ran into doing the cross compilation. Was it kind of a pain? Here we go. What year is this? 10 months ago. Oh, not that long ago. I did this more recently than I thought. I was not on a different desktop. I just moved it off screen while I was digging through my GitHub. Okay, so here's one thing I did was, okay, I want to write a main.c, and I had to include the header file. I had to do something, I don't know. Check for the boot pin, and then just while true, blink a pin. But LED pin here is defined here, and I wrote a script that I think it's probably makefile. Oh yeah, so like this is my basic makefile, and I was like, I hate this. So this is part of like my quest for a better embedded build system is like all this sort of stuff too. All this templating thing. Although startup code is part of that too. Is something I'm thinking about. But I guess I didn't do it. I didn't do it here. There's also the example, it must be in the other one. Okay, so it's not in here. Let me do some digging off screen again. It was for the, what is it called? The low power CPU. It's been a minute since I did this. What do they call it? LPU? No. What do they call it? ULP, that's what it is. Okay. So, bare makefiles are crime. Yeah. I have visions that this like Python toolkit for building embedded projects could actually do basic linker, basic startup code, all that stuff for you. libc, compiler runtime just manages it all. Like it already has things of functions that just say build this, build that, build this, give me the linker script, whatever. Like helpers like that. Okay, so we used to have ULP support. So ULP is a coprocessor on the S2 and S3 and the ESP32. Before I talk about this, before I get into these weeds, let's just push this change and let the CI run again. Always define. Which one is it? Let's see how many things that fixes. MS-DOS sources are also used to build with Make. Yeah, not surprised. Make has a long history, which is why people are comfortable with it. But part of the reason I'm okay saying just do it in Python is because I see everybody who's doing build systems is also doing Python, right? They're wrapping their build system in Python, or they're calling out to some script that needs to do something that is detailed to Python, or that like Make can't do, which we have a ton of, and we have this. I don't remember who added it, but a little rant, sub rant. In the Micropython build, there is this makeqstrdefs, I think is what it is. So this is like, we pre-process all of our C source, and then we run this Python script on it to find all the Q strings. And that's a lot of files. So look, it's calling subprocess run from a multiprocessing pool. So it's doing concurrency for you for something that Make is calling. And I'm just like, and I get errors out of this because like if the preprocessing is not able to find headers and stuff, like there's things there too. It's just, yeah, not a new tool. Okay, back to this. So in my mind, this like external device that you're controlling from Python, the ULP is like that as well. So here we're using a make file because it's a make file. We build blank, and then we have our elf target, but then we can also use clangd to dump information, the AST of the C code. And then we run a generate Python off of that. So we take the elf and we take the AST, we run this gen Python script. So what it's doing is it's saying, okay, here you have a C source file. I will generate a Python wrapper around it that you could use in CircuitPython. And it includes all of your binary. So like you could, in theory, say ship a library in the CircuitPython bundle or circup, and it literally includes like the compiled version of the code that runs on the other device and loads it for you. And it also generates I don't know, did I include the, right, okay, so here's an example of, ignore the struct memory thing. So here's the like generated output. So you have this class blink and it has a property delay. You can initialize it. You can give it the LED pin. You can get a version, so S2 or S3, and you can give it delay. So the generated, this is all generated, but you get, okay, I'm going to start up the ULP. I'm going to halt it. Here's my program. Oh, and by the way, like I've pre-compiled it. Here's my program. I'm going to self pins append, which I don't remember what that's for. Oh, I guess we give it to ULP run. But then what we do is we actually, because we looked at we know stuff about the ELF, we can actually patch it. So the things that you do when you start it, you actually patch the binary before you load it. And then we also have this thing in CircuitPython called memory map, which gives you just straight read-write access. And this struct memory thing actually allows you to change delay dynamically. So you have blink, you say blink, and give it these 3 arguments. How is the AST used in the blink example here? I think the AST is used to figure out the globals. So the globals are, let's see. So here's 2 examples, sleep, pin, wait. So the ULP wraps a C binary in Python thing would be kind of like loading firmware blobs. Yeah, kind of like that. It's like some Wi-Fi chips and USB stuff does too. Yep, yeah. But not only am I'm also generating like the API to it. So I'm looking at Blink and I'm saying, okay, so the pin to Blink, the version, and then, oh, I mark things I want to change on the fly as volatile. And the reason to do that is that you need to make sure that the compiled version, so main.c, will actually load from memory again, because you're having something write to memory and then this other core is spinning on it. So you have, I don't know what this stuff is. This is like some boilerplate stuff that I think is generally supposed to go around it. So not all of this would be kind of in your original source file. So let's look at GenPython. So here we say, okay, let's look over the AST. It's a JSON file. Inner must be like the top level. Oh, if it's a variable declaration, blah, 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 I don't know. Implicit cast, I don't know. Oh yeah, it takes comments out of it. I didn't even remember doing that. And then it has some notion of like types. It can do smarter type conversion. You could do as well. And then you open the ELF, you get symbol table, you find all your symbols, you figure out where they are to patch them. And then, yeah, so the struct memory thing is boilerplate. You create a new class. Volatile variables are class descriptors. So these are like attributes on that. And then parameters, yeah. So this is a like, and if I remember right, part of the problem is just like bootstrapping the build process for these. Like in theory, it's just a small tiny chunk of main.c code. It's like kind of a pain. So, yeah, like you've seen these make files. It'd be super cool if it was just like a Python tool. So Sam says, so you're imagining a setup where you can use this thing as a regular CircuitPython library, but there's a mechanism for something like automatic port-specific firmware blob SDK binding generation. So there's 2 worlds that we're talking about. The world that I've sent you down, because you seem interested in it, is the OrangeCrab world, where it's like a custom sock on CircuitPython. That's not this dynamic stuff. Generally, like this is a weird case for the ULP, the processor inside of the ESP chips. But generally what I've been thinking about, the thing I'm targeting first in my mind is actually like the stemma G0 case, or even the C0, which is even cheaper, where you have a microcontroller that you can use to do some other task for you externally. Whereas like we have Seesaw right now, but we don't load Seesaw code over over I2C. We kind of like have to ship with Seesaw on it, and the Seesaw firmware generally does everything that you need, so the API surface is really large. But what I'm imagining for like the C0 and the G0 is that we have some code that does like I2C management for you. You're like using it as this bridge of like, I want to read or write this variable or that variable. So it would still be like from Python, you have attributes that you just say that you read and write from, and then those do I2C transactions to the other core implicitly. Yeah, so I'm thinking of it more in the stemma case, where you would say like, I'm loading this device with this library, and now it's going to do this or that thing for me. Right. This ULP tool is very cool. Since this uses clangd to inspect the C code, it doesn't apply to RP2040 PIO code. Right. That's correct. This does not apply to PIO. Although you could manually do something similar for PIO. PIOs don't have general memory access. So it's similar in the way that like you could have a PIO library that ships, or a PIO-based library that ships with something. It's meant to be a little more general. But I'm thinking like this build system that I'm thinking about would make building tiny, small main.cs for C0s or G0s like way easier. And then if you're doing all Python, you can integrate them directly together. No makefile. No makefile, just a kind of build this .py. And one thing I did, so right now it's just called embedded. But one thing that this library does, I think I should rename it to Embedded.build, but there's a CLI. So part of my thinking is that it would be cool, like you want to have build subcomponents, right? And this is like CMake subprojects. But what I want is I want to have an API, a function API service kind of around those sub-projects, right? So I want to be able to say like, hey, I want to build pickel.libc for this CPU with this compiler, and then have some pickel.libc custom keyword args that allow me to customize how I want to build it. But I also want to like be able to, I want to have that as an API call, but then I want to be able to call that subprojects on its own. So I need something, this code here inspects the function that would be called and kind of like gives you parameters to set all those things automatically. So you worry about the function API surface, and then you can also get a command line interface to that as well. So maybe the overarching idea would be a better way for using coprocessors on cheatboards to help sling pixels quickly. That is one example. Another classic example is like rotary encoder monitoring. Would be super easy to offload to another core, right? So it's like general, like I want to offload this computation or monitoring to some other core. It's kind of funny because like that's what microcontrollers are for. So now it's like, you know, people want concurrency in CircuitPython, but it's like, well, like especially if you need something time sensitive like rotary encoding or key matrix monitoring, like maybe it's actually better that we just like offload it to another MCU. Less glitchy knobs, right? Like it's a generic, like I just need this tiny piece, and maybe like Lamore's way to do it, because she's more comfortable with Arduino than I am, is to actually write an Arduino sketch to do something, right? So maybe we have the same sort of tooling around an Arduino sketch. But Arduino does some kind of crazy build things. So like, why not just do this like, I was even thinking about this, like, what if you even had a header that was generated by the build system? So you just said like pound include embedded / microcontroller.h, and it includes like the SimSys header for all your registers or something, right? And you can do things like pre-compile headers too, so you can like pre-analyze headers to make them faster to import. Apply this ULP stuff to wrap Arduino stuff. You could, but I'm more comfortable in just plain C. Anyway, so that's brain dump time with Scott, which is what deep dives are. But I also realized last night, I think it's kind of neat, import embedded and from embedded import CPU and microcontroller. Unfortunately, I tried to push to PyPI as embedded and it's blocked. I can't be just embedded on, I can't just do pip install embedded. They blocked it for some reason. As far as I can tell, there's no other project, but like they have some stuff that they just block by default. So on PyPI, it's python.embedded.build, which I think I will actually rename this repo too to just match it up. And then the import will still be just embedded because it looks nice to me. I just did this last night and it made me feel kind of like I was going the right way. And I also had the realization last night that I've been working on this build pickel wrapper, and like I could just totally put it in here. So like having an embedded libraries thing and just allow you to say like, oh, I want to build pickel, and then it will go fetch the source for you and build it using your arguments. Like, why not? Like for things that are like, or tinyusb, right? Like we could have a builder here for tinyusb in this repo too. Like, how cool would that be? And then like for configuration, you just have keyword args or like higher level structures that you fill out. I don't know. My brain is there. My brain is a bit obsessed with this build stuff right now. Which is why I'm like, maybe on my trip with my dad when like we spent all day in the car together and we're kind of like zoning out on our computers, I could just jam it out. Take a little holiday break for myself. Okay, I have another window with the CI stuff. This was fixing, I doubt it's green, but it's probably better. 9. We got it down to 9 failing things. Okay, let's take a look at this and then we'll call it a, oh, and it's all Raspberry Pi stuff. Interesting. Oh, it's Raspberry Pi stuff and, oh, okay. This is an easy fix. So I got rid of the CircuitPy USB define, which we talked about how I'm thinking about configuration stuff, and I haven't even talked about all of the pound defines that are also a problem. But at least by refactoring the build system, we could limit, like, we could say like, for building this file, whatever file this is, like CY43 lwip blah blah blah, like limiting it down so that we don't give every single pound define on the command line. Whew. Okay, so this is all for all the PicoW stuff. Let's switch to ports, Raspberry Pi, and we'll make a board Raspberry Pi Pico W. And we'll clean it. And we'll J32 it. And we get the same error. Great. So in CYW43 config port, which I'm trying to train myself to do, CYW43 config port. I asked Dan to get rid of all these. Although that one we might not do. Device. I just renamed it because I wanted to make it clear because with this change, we'll actually have tinyusb on boards that don't have USB device support. So like the C3, C6 will have tinyusb only for the host stack. So that's why I renamed it. To try to make that, start to make that clearer. And instead of doing CircuitPy USB, I have a new CircuitPy tinyusb as well. That is like if any tinyusb is included, which I could do here, but generally this is the right way to go. Okay, so I'm gonna assume that all of these are fixed by that change. They're all the same problem. And then the simul thing is also, it's failing. Oh, it's a Nordic board. Okay. So let's fix this too. I think it must disable USB or something. Ports, Nordic, boards, simul. Oh, interesting. It turns off USB CDC. And MIDI. Okay. Is that the same for the plain ESP32? Support with USB host only. It is. Yep. Yep. Undefined reference. Oh, and we're doing LTO. So we can't tell. We're in serial write substring. So we think we're not including everything that we should. And I think that's because of makefile. The makefile! After all this ranting about build systems, I've ended up needing to change supervisor.make. So I think it's because I moved this. Like, I think I moved that. And this is a world where we don't have USB CDC, but we do have device. And we still need it. USB CDC means the module, not the functionality. See, for logic like this, it should just be in Python. Python's a much better place to define logic like this, in my opinion, obviously. Welcome to Scott's 2 hours of his opinion. Any other questions before we wrap up? Thank you for humoring me on all my big brainstorming and ideas and stuff. Okay, that worked. So let's stage that and stage that. Fix CYW43 and without USB CDC. Is there an area where the Nordic NRF stuff shines over the other CircuitPython targets? Yes. Low power. The NRF 5240 is really nice for low power. It's also great for BLE. Our BLE support on Nordic is the best. It's the only way to do BLE HID currently. That's like what I'm working on for Espressive. But even once Espressive supports it, you're not going to get the low power that you do on a Nordic device on the NRF 52840. So it's great for that. And then it's also great compared to the CMD21 just because it has more RAM. So like SAMD21, like that's why we have the circuit playground Bluefruit. Not only do you get BLE, but you just get more performance, and you get more performance because it's an M4, not an M0, and it's slightly clocked faster, but it also has like 256K RAM instead of 32. Anyway, there's a place for Nordic stuff, and at some point we'll get back to it. Like they've announced their next chip, but it's not available yet. Although I was sitting next to somebody at the conference that works on Nordic, and we were talking about 54. We were talking about compiling Clang, and also it's a beast. It's a beast. It's multiple M33s clocked up to 320 megahertz, multiple RISC-V coprocessors, and a meg of RAM. So like, we haven't done a lot of Nordic work recently, and this chip is kind of unobtainium right now. But like at some point, and it's got high-speed USB, at some point it will be available. Who knows how much it'll cost? But like, that'd be pretty neat. And having a better build system that can manage, like, I was sitting next to Carlos, who's one of the main Zephr folks as well. And like, they've done a lot of work in the build system for Zephr to be able to manage things as well. Someone says, I'm counting the days for when they finally release the 54H20. It has to be soon. Who knows? Espressif announced last January, like over a year ago, the P4, and that's still not available as well. P4 is similarly like beefy like this, except it has no radio. The P4 I'm also excited about. That's a reason to keep up to date with the ESP IDF. It's in the low cost market, so I'd expect it to be won't be very expensive comparatively. We'll see. That seems like pretty high spec. There's actually another one in the 54 family though, that they've announced, I think. No, they don't even have it on this page. Bluetooth low energy, 54 series. Oh yeah, the L15. Yeah, so they're sampling it now. I'm not sure anybody outside of Nordic actually has it. So this is a 128 megahertz ARM Cortex-M3 with 256K RAM. A software-defined peripheral enabled by a RISC-V coprocessor. So that's kind of interesting. This is kind of like the post-RP2040 world, where like PIO is super cool, but you could just put another core there and do the same thing. So maybe that's where that's coming from. I don't think this has USB, but maybe it does. It's still quite unobtainable. It says new peripherals, but it doesn't necessarily tell us whether it has USB or not. Anyway, I think we'll get back to Nordic stuff. Their low power stuff is really good. ESP, I think, is getting there. And the C series, we need to do low power on the C series as well, on the ESP32 C6 in particular, probably. So, always cool stuff. Always cool stuff. If you're interested in any of this stuff, please reach out to me. If you want to get into a Python build system, let me know. But my brain is so stuck on the build system stuff right now that I'll probably do it tonight. Probably work on it tonight as well. And I'm using it for Clang, for the Clang work of getting CircuitPython on Clang too. But at this point, I'm really like, I'll probably just change it all. We'll see. Hams Lab says, are you folks considering adding Matter things to CircuitPython? We are. It's definitely on our radar, especially when Lamore was looking at the C6. what I would like so that I understand it better, I don't know if I'll do the work or maybe Dan or Jeff, but if you have an existing Matter supported device, and the one that I was trying to look for was an RGB light, right? We specialize in neopixels, let's be real. And there is a way to make a kind of standard Matter RGB light. So if you have one that I can purchase and just try and see how it works, like I think that's where I would start for Matter. The other place you could do is like sensors, like temperature sensors and stuff. But if you have Matter devices that you think work well and kind of demonstrate the promise of Matter, let me know. I already have an Apple TV, which it should work with. Like, if you have example devices that you'd love to be able to DIY something equivalent in CircuitPython, send it my way. Like, that would be super helpful for us to like scope down what we're trying to achieve. That reminded me, the other use case I have for this like stemma G0 thing is I really want to, so, you know, one thing that CircuitPython excels at is being an interface, like a keyboard, mouse, gamepad, knobs, whatever, an interface and then into something, right? The thing that I've felt is missing that I really would like to prototype, and I have a bunch of cables, is a patch panel. I would love to come up with a way to have an extensible, connect this to that, and under the hood have I2C know that such and such was connected to such and such, and then your code can do something based on that. SynthIO is super powerful now, and so like you could imagine saying, oh, I found out that this was connected to this, and now I want to like change my how my objects are connected in CircuitPython, which I think would be amazing. I can put something together on ESP32 to control NeoPixel or dot star. When I get it done, I'll let you know. That'd be great. An ESP IDF example would be really helpful too. Tyus says, thanks Scott for the stream. Seems like the next /current, what was it, 1.3 version of Matter revision will bring the dream closer. Seamless pairing, etc. But to be fair, seems most people accept Zigbee bridges. You know more than I do. Okay, let's get out of here. I'm over time, and I'm just, you got me all fired up. I haven't even had caffeine today. Well, besides the chocolate. But like, come on. Build systems get me fired up. Or more specifically, less than ideal build systems. That is the world that we've been in forever. In my opinion. Thank you, everyone. This has been a pleasure to hang out with you. This has been Deep Dive with Scott. I do it 2 p.m. Pacific here on the Adafruit streams. Adafruit pays me to work on CircuitPython and ramble about build systems on a live stream. So if you want to help me help them, go to adafruit.com, purchase some of our different board designs there. That goes to paying me and a bunch of other really awesome, helpful folks. If you want to chat when the stream goes away, I always point the wrong way. And if I point this way, I'm like, that's where it is on my computer screen too. I don't know. You can join the Discord server by going to the URL adafru.it/discord. Check it out there. Check out CircuitPython if you haven't. I know I didn't show a lot of it today, but it's cool, in my opinion. I'm biased, obviously, but and I think that's it. I should be here next week, assuming that I'm healthy enough and my family's healthy enough. But the next week I will be gone. Yeah, let's take a look out the window and get out of here. It's gotten nicer. I don't know if you noticed it, but there's fewer clouds, more blue sky. All right, thanks.